Hello friends, welcome back to our channel. So in today's session, we'll discuss one more example in solving higher order recurrence relations. So in our previous session, we have seen the higher order homogeneous recurrence relation, one example in that, and now we'll solve one more example. So this is the question. So an plus an minus 1 minus an minus 2 minus 12 an minus 3 is equal to 0 where n greater than or equal to 3 and given some initial cases. So first step, we have to check whether it is, the order of that particular given recurrence relation, given equation. So what is the order? So highest subscript n minus the lowest subscript n minus 3, which becomes n minus n plus 3, which becomes 3. So this is a third order recurrence relation. So this is a third order recurrence relation. Now we have to check whether the given relation is in third order, because for any third order the n value should be greater than or equal to 3. So obviously in the question itself we have given some n is equal to greater than n greater than or equal to 3. Yes, that is in third order. Now the next step, we need to form the auxiliary equation. So here what we have to do, an should be replaced with a third order, so it is an a cube, an minus 1 with k square, and an minus 2 with k, and an minus 3 with k power 0. Okay, now use the same thing. Auxiliary equation will be k cube plus an minus 1 k square plus an minus 2k. So here it is, constant is minus 8. So minus 8k minus 12 is a constant and k. So minus 12, k power 0 means 1. So that becomes 0. So this is the auxiliary equation. So we had an auxiliary equation. So this is a cubical equation. If it is a quadratic equation, directly by using the formula minus b plus or minus square root of b square minus 4ac by 2a, so we can get the roots. But it is a cubical equation. So for any cubical equation, we can follow the synthetic division method. In our previous session, we have explained that synthetic division method. So I'll post the link in the description. So go through the first example so that you will be knowing clearly what about the synthetic division. So now also we'll use, write down all the coefficients of this equation. Okay, this is a cubical equation. Write the coefficients. So coefficient of k cube is 1, coefficient of k square is 1, coefficient of k is minus 8, quotient of k power 0 is minus 12. So by trial and error method, we can consider the initial value as a root. So I'll consider 1 as a root. Okay, 1 as a root. So start with 0. So add these two things, 1 plus 0, it is 1. Multiply these two things. Okay, so this should be addition, this should be multiplication. So 1 into 1, it's 1. Addition, it's 2. 1 into 2, it's 2. Minus 6. 1 into minus 6, it is a minus 6. So it becomes minus 18, which is not 0. So we can say 1 is not a root. If you got this particular position as 0, then we can say this particular value as a root. But here we are getting minus 18, so 1 is not a root. Now, just by trial and error method, we will be going with another number 2. Let us check. The initial value is 0 itself. 1, 2 into 1, it's 2. 1 plus 2, it is 3. 2 3s are 6. It's a minus 2, it will be minus 4. Okay, so you can observe, if you go on, if you keep on going with the numbers, so we are getting here the negative number, but we'll be getting 0 if it is a positive 12. Okay, see, for example, let us take 16. So this is not valid. If you consider 3, what I said means we have to use a trial and error method. So here instead of 2, I am taking 3. 1, 3 1s are 3. It will be 4. 3 4s are 12. So what happens? It is minus 8 plus 12. It is 4. 3 4s are 12. Yes, we got it. Okay, yes, we got it. So by using 3, we are getting the result as 0. So obviously we can have 3 as a one root. 3 as one root. So because see, what happened means, if you are not getting with the positive numbers, you can also try with the negative numbers, because the roots may also be negative number. But here luckily we got 0 if the root is 3. So this part is 0, then we can say the k1 is equal to 3. K1 is equal to 3, right? Yes. Now you can follow the same procedure. You can follow the same procedure, but you can also convert into a quadratic equation and you can find it. So this can be converted into quadratic like x square plus 4x plus 4 is equal to 0. So from here we can write this one, x square plus 2x plus 2x plus 4, okay, is equal to 0. Now you can simply take x as a common, x plus 2 plus 2 as a common, x plus 2 is equal to 0. Then obviously x plus 2 is equal to 0 and x plus 2 is equal to 0. Then it becomes a minus 2, it becomes a minus 2. So the other roots are k2 is a minus 2 and k3 is also minus 2. Okay. So hope you understood. So in order to find the roots of any cubical equation, you can first you can use this synthetic division method. So by taking the values randomly, okay, trial and error method, we can check whether this value is a root or not. If the last position value we get 0, then obviously we can say the taken value is a root. So here we got a root. And what about the remaining 1, 4, 4? So simply create one equation, auxiliary equation. Now it becomes a quadratic equation. So directly you can use this method, or you can also use the quadratic roots of quadratic equation formula, right? So finally we got a k1, k2, k3 as a values, right? So you can observe. So now we have to select the cases. What is the first case? First case is, I'll write here. Case 1 is distinct. That means all the three roots are different. Case 2 is equal. So if all the roots are equal. Case 3 is imaginary. Roots are complex and imaginary, right? So this is not, we are not able to use this one because roots are not imaginary. So here the roots are, two roots are equal and one root is different. Okay, two roots are equal and one root is different, right? So not completely this one, not completely this one. So if it is distinct, all the three roots should be different. If this is the case, we have to follow all should be equal. But this is a combination. This is a combination. So how we can write? We have to combine case 1 and case 2 and get the formula. Okay, you have to write down the formula, right? Because here among three roots, two roots are same and one root is different. So what is a distinct formula? I'll write the formula here. For the distinct formula, what is the formula here? Distinct formula, a into k1 power n plus b into k2 power n plus c into k3 power n. And equal formula, a plus b into n plus c into n square into k power n. So we need to combine these two things. So because two roots are equal, we have to use this one. So this is completely wrong, right? We did not follow this third one, right? So I'm erasing this one. So among from here, two roots are equal. When two roots are equal, what we have to do? A plus bn. Okay, there is no third term. Into k1 power n. So let it be k1 or k2 or k3, whose roots are equal. Okay. Plus, what is the difference? Third, I mean, if the roots are different, this formula. What is it then? C into k power 3. So C into k3 power n. So let us take this as without any confusion. Okay, you can take anything. So without any confusion, k1 is equal to k2 is equal to minus 2 and k3 is equal to 3 because the roots are 3, minus 2 and minus 2. Now this is the general solution we need to find out for given recurrence relation. Hope you understood. So this is a case we will be getting in higher order recurrence relation. So such type of things we will not get in second order or a first order. So we'll face the same kind of problem in the higher order recurrence relation. So based upon the roots, we have to create a formula. We have to define the general solution formula. Okay, so here once again I am repeating, here two roots are equal, one root is different, so we are combining these two cases and we are defining the general solution. So now we have to find out the constants, whatever the constants. Here what are the constants? A, B, K, C, K3. We know that K1, K2, so it can be either K1 or K2, okay, because both are equal. So we need to find A value, B value, K value, K1 value, C value, K3 value. We know already K1 and K3. We need to find out A, B and C and then substitute this in this particular formula. I highlight the formula here. An is equal to A plus b into n into k1 power n plus c into k3 power n. So am I erasing all these things? So we know k1 is equal to k2 is equal to minus 2 and k3 is equal to how much? 3. Yes. So I'm erasing all these things because we need to solve the equations to find the constants. Okay. Now see, this an is equal to, what is the formula here? A, we don't know a value, plus b into n into, what is the k1 value? Minus 2 power n plus c into k3 value 3 power n. So this is the formula. Okay, so we know the initial conditions. Okay, initial conditions, a not equal to 1. Let us take a not equal to 1, so n is equal to 0. So in such case, a naught is equal to a plus b into 0 minus 2 power 0 plus c into 3 power 0. So it becomes 1 is equal to, so this becomes 1, this becomes 0. So a plus c, a plus c is equal to 1. Okay, so I'll write this one as a plus c is equal to 1. So this is the first equation. Now let us take a1 is equal to, what is the value? 5. So n is equal to 1. Now it becomes a1 is equal to a plus b into 1 minus 2 power 1 plus c into 3 power 1. So it becomes a1 value, it's a 5. So I'll write the expression on left side and the value of a1 on right side. So minus 2a minus 2b plus 3c is equal to a1 value. What is a1 value? It's a 5. So this is the value we are getting. Next, a2 is equal to how much? 1. So n is equal to 2. So a2 is equal to a plus b into 2 minus 2 power 2 plus c into 3 square from this. So now we will write minus 2 square. Yes, minus 2 square means 4. It will be 4a plus 8b plus 3c is equal to how much? 1. Okay, minus 2 power 2. So here we are getting k1 as minus 2 power 2, which is 4. 4a plus 8b plus 3c is equal to 1. So this is a 1 more. Right? Now, we need to find the values of a and c, a, b, c. So from this part, we can write a is equal to 1 minus c. So substitute. So let it be, this is a equation 1. Okay. Now substitute equation 1 in okay, substitute a value in, let it be 1, let it be 2, let it be 3. So in 2 and 3, we'll be getting two expressions. So first I'll substitute a in 2. So minus 2 into, what's the value of a here? 1 minus c minus 2b plus 3c is equal to 5. Expand this one, minus 2 plus 2c minus 2b plus 3c is equal to 5. So it becomes 2c minus 2b plus 5c is equal to 5 plus 2, it will be 7. So one equation we got it. Let it be, it is 4. Similarly, substitute a value in 3. I'll write so there will be no confusion. Substitute a value in equation 3. So what's the equation 3? This one. So 4 into 1 minus c plus 8b plus 3c equal to 1. Now 4 minus 4c plus 8b plus 3c is equal to 1. So what becomes? Minus 4c, so it will be 8b minus 4c plus minus c is equal to 1 minus 4, it will be minus 3. Okay, hope you got it. 8b minus c is equal to minus 3. So this will be the equation 5. Now we need to solve 4 and 5. Okay, we need to solve 4 and 5. So what is the 4? Here we are having 8b. So we can multiply 4 with 4. 4 into equation 4. That becomes minus 4b, sorry. 4 into 2 minus 8b plus 4 into 5. 20c is equal to 4 into 7. So 28. Next, equation 5. Equation 5. Okay, what is equation 5? 8b minus c is equal to minus 3. So what happens if you add it? Okay, if you add it, it becomes 19c is equal to 28 minus 3. It will be 25. Okay, 25. So c becomes 25 by 19. 25 by 19. So here c becomes 25 by 19. Now what we have to do, based upon c value, we can find a value. Okay, so I am erasing this part. Hope you understood this part. So I am erasing this one. Yeah. So we know that a is equal to 1 minus c. That implies 1 minus 25 by 19, which becomes 19 minus 25 by 19, which becomes how much? 6. Minus 6 by 19. Minus 6 by 19. So here a becomes minus 6 by 19. Now we need to find out the b value. So we know that minus 2b plus 5c is equal to 7. Okay, so minus 2b plus 5 into, what is the c value here? 25 by 19 is equal to 7. So calculate this one. So 2b is equal to, okay, so how much it becomes? 5 into 25. 5 into 25. So 125 by 19 minus 7, which becomes, so how much it is? 19 sevens. Okay, so 3 6 716 717 133. So 125 minus 133 by 19, which becomes how much? What is the difference here? I think it's 8. Okay, minus 8 by 19. So b is equal to minus 8 by 19 by 2. That means it will be 38. Minus 8 by 38. So here b value is minus 8 by 38. Okay, now we know the values of a, b, c, k1, k2 and k3. So simply you can apply all the values in the general equation. Okay, So I'm writing here A value is minus 6 by 19, B value is minus 8 by 38. So it can be reduced. Okay, minus 8 by 38 means minus 4 by 19. It can be reduced. Okay. Next, C value will be 25 by 19. K1 is equal to minus 2. K2 is equal to minus 2. K3 is equal to 3. Now what you can do? So A general solution AN is equal to A minus 6 by 19 plus B minus 4 by 19 into N. K1 minus 2 power N plus C. What's the C value? 25 by 19 into K3, 3 power N. 3 power N. Okay. So hope you understood. So this is the general solution for the given higher order recurrence relation. So you can also cross check whether it is correct or not. How? So we know the initial values A not equal to 1. Apply N is equal to 0 in this one. So A not value minus 6 by 19 plus minus 4 by 19 into 0 minus 2 power 0 25 by 19 into 3 power 0. So it becomes 0, this becomes 1 and this becomes 1. So this becomes minus 6 by 19 plus this part becomes 25 by 19, which becomes 25 minus 6, which is 19 by 19, which becomes 1. See, A not equal to 1. We are getting A not equal to 1. Similarly, you can also substitute N is equal to 1 and definitely you will be getting the result as a 5. So if you got these values, we can say the procedure is correct and the roots are correct and the general solution is also correct. Okay. So hope you understood. So the only major part we have to concentrate is the formula should be generated based upon the roots. If we have defined the formula for only the three cases, if the roots are equal, if roots are different, and if roots are imaginary. So we may get some roots as equal and some roots as a different. So in that case, we have to join two cases and we have to create a formula. So the same thing happened here also. Here among the three roots, two roots are equal and one root is different. So we have defined a formula based combining case 2, case 1 and case 2. So if we are moving on with a more number of, more order, that means a higher order other than 3. So we may get a more number of roots. Then we may combine all the three cases and we may define the formula. So the only complex thing is defining the formula in higher order. That's particularly in the higher order recurrence relation. Right? Yes. So hope you understood. I'll post the previous links in the description, the complete discrete mathematics playlist in the description so that you can follow. There you can find the procedure for solving the first order, second order, and similarly the higher order. All the different cases. Okay, yes. So just follow that, you can understand. This is a very simple concept and we are also very important concept. Yeah. So let's stop here, and if you are having any queries regarding this procedure, feel free to post your doubts in the comment section. Definitely I'll try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.